Welcome to Session 2. The Pythagorean Theorem is more than a formula. It says that for a right triangle, the area of the square on one leg plus the area of the square on the other leg exactly equals the area of the square on the hypotenuse. Seeing that relationship makes the equation easier to remember and use correctly. The equation is a squared plus b squared equals c squared. The letters a and b are the legs. C must be the hypotenuse. We square each length because the theorem compares areas built on the sides. Adding a plus b is a different operation and does not give the diagonal. Use the classic 3, 4, 5 triangle. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25, and 25 is 5 squared. The two smaller square areas fit the largest exactly. That equality is the signature of a right triangle. The converse lets you test 3 side lengths. Put the longest length in the C position. Square the two shorter sides and add. If their sum equals the square of the longest side, the triangle is right. This turns the theorem into a practical tool for checking corners and classifying triangles. For side lengths 8, 15, and 17, 17 is longest. 8 squared is 64, and 15 squared is 225. Their sum is 289. 17 squared is also 289. The values match. Now, test 6, 8, and 11. 6 squared plus 8 squared is 36 plus 64, which equals 100. 11 squared is 121. The values do not match, so these sides do not form a right triangle. The theorem only applies when a right angle is present or proven. Do lengths 5, 12, and 13 form a right triangle? Treat 13 as C. 5 squared plus 12 squared is 25 plus 144, or 169. 13 squared is 169. Yes, the equality confirms a right triangle. You now understand both the theorem and its converse. Next, we use the equation to find an unknown hypotenuse and handle square root answers. Continue your GED preparation at www.bridgetoexam.com.